been a good time. So we're going to spend 2 days. The first day we're going to talk about linear approximation. And so I've drawn a function, f of x, and I've drawn the linear approximation, which is just simply the tangent line. So you see that in blue. Now, the whole idea behind this is if you were to zoom in on the spot of tangency, which I will call x sub 0 and f of x sub 0, that spot, if you zoom in on there, wouldn't you agree that the blue line looks remarkably similar to the actual function? I mean, it's not going to be exactly the same, but as you zoom in, they start to look quite a lot like each other, don't they? And so what we learn is that the linear approximation, or the tangent line, can be a great approximation for the actual function value. So if we were to write an equation for the line, we would say that we need a point on the line, which in this case will be x sub 0 and f of x sub 0. And then we also need slope. Now, if you've learned anything at all this year, please tell me, what do you do to find slope? You take the derivative. So the derivative will be f prime of x sub 0. So the equation for our line will then be y minus f of x sub 0 is equal to f prime of x sub 0 times x minus x sub 0. Or in other words, y equals f prime of x sub 0 times x minus x sub 0 plus f of x sub 0. It's really not that big of a deal. I just want you to see what sometimes people use as an equation for linear approximation. We'll just simply talk about the equation for line tangent, but that's the notation that's used in your book, and often you may see it pop up like that on the AP exam. So the question is, why would the linearization of a function be useful? It helps us approximate function values that are difficult to calculate. Now, the example we'll look at today is, just picture Isaac Newton, kind of one of the fathers of calculus, back in the 1600s, sitting down and saying, boy, I'd sure like to know what the square root of 4 is. Well, that's pretty easy, right? That's 2. But suppose he said, I'd sure like to know what the square root of 3.99 is. Well, you would take out your calculator and you'd punch in square root of 3.99. We don't even know how it comes up with the answer, do we? Many of the functions that your calculator uses are based off of calculus principles. Isaac Newton would often not come up with the exact value out to, say, 8, 9, 10 decimal places, but he would be correct to say 4 or 5 decimal places, and he could do it really quickly. And that's part of what we'll show you today. Now, the applications go above and beyond that, but that's just a very basic one. So we're going to find the linearization, which just means the equation for the tangent line of 4x squared minus 1 at x equals 1. And so we're going to need a point, and point on our line, which is 1, and then what's the y value going to be? 3. And then we need slope. In order to find slope, we need to find f prime of x, or y prime. What is the derivative? 8x. Plug in 1 and we get 8. So therefore, the equation for the tangent line is y minus 3 equals 8 times x minus 1. Or y equals 8x minus 5. That's your answer. That's the linearization at x equals 1. So what that means is if you were to sketch a graph, so there's 4x squared minus 1. It shifted down 1 unit. If you were to draw the tangent line, it has a slope of 8. It goes through -5. You know, it would look something like that, right? Now, here's my question to you. You can see that, you know, at a point which it touches tangent, which I haven't drawn this real accurately, but, you know, the parabola and the line basically look exactly like each other. But here's the other point. Is the line above or below the parabola? Below. So the line gives an underestimation of what the actual value is. Can you see that? So that's an important thing to note. Let's go to our next one. I know you guys love trig, so I brought in a trig example here for you. Point on the line will be pi over 2. And what about the y value? I plug in pi over 2, and I get 2 times pi over 2 is pi. What is the sign of pi? So sign is going to be the y value, so it will be 0. In order to find the slope, I need to take the derivative. I have to use the chain rule to find the derivative. I have negative sine of u, and I have 2x. So I get -2 cosine of 2x. In order to find the slope, I plug in pi over 2. I get pi over 2 times 2 is pi. What is the cosine of pi? It is -1. We multiply that by -2, and we get 2. So therefore, I have y minus 0 equals 2 times x minus pi over 2, or y equals 2x minus pi. And that's the linearization at x equals pi over 2. I want to be clear that it's important that we say the linearization at that point, because it's only at that point that the line really looks like the function. It may not look like the function at any other point. I'm going to quick sketch the graph of this. Can anybody tell me what the period of this graph is? Sine of 2x. 2 pi divided by 2 will be pi. I divide it up into 4 parts, so I have pi over 2 in the middle. And max value of 1, minimum value -1. Sign gets started max, min, or middle? Middle. And will this one start by going up or down? Down. So just had an excellent trig teacher last year. You remember this very well. Good job. And you're going to draw the graph in y equals 2x minus pi at pi over 2. You can see it's going to look like that. Now you can see that if you move to the right, the line is above. It's an overestimation. But if you move to the left, the line is below. It's an underestimation. So we have to understand the graph in order to determine if it's an overestimation or an underestimation. You okay there? All right. So this is the last piece that we're doing today. Then you can have your assignment. It says find the linearization of f of x equals the square root of 4 minus x. Before I find the linearization, I'm going to sketch a graph of it. What does the square root of 4 minus x even look like? Shifted to the right. How many units? 4. And will it head off to the right, or will it head off to the left? The left, due to the negative in front of the x, it is a horizontal reflection. Very good. Now, part of what I want to be careful about is this, okay? If I plug in 0, I end up with the square root of 4, okay? If I plug in 0, all right? And so we will identify the point at which we want to use the linearization. So we have to find a point on our line, and we have to find a slope. Now, because I'm going to approximate the square root of 3.99 and the square root of 4.1, those values are both close to what? 4. So therefore, x will be 0 because that would give me the square root of 4. You see that? A lot of people don't know what to choose for x. We're going to choose x to be something that would give us values very close to these. Okay, so if x is 0, what would the y value be? 2. I want to find the slope. How do I find the slope? What do I have to use for the derivative? U to the 1/2. 4 minus x. Derivative of 4 minus x is -1. What's the derivative of u to the 1/2? So it looks like I got -1 over 2 times the root of 4 minus x. If you plug in 0, we get -1/4. And I get y minus 2 is equal to -1/4 times x minus 0. Or y equals -1 over 4 times x plus 2. That's my linearization at x equals 0. I will draw the line that's tangent. Tell me, is the line an overestimation or an underestimation? It's an overestimation. So anything we get as an output for our estimation will be above what it should actually be. Question. Does the line sit above or below the function? Better? Okay. So we are now going to come up with some approximations. I'm going to make an x and y table. I would like to approximate the square root of 3.99. What should I then plug in for x? 0.01. Why, Austin? Because 4 minus 0.01 gives me 3.99. What do you think sometimes people will plug in instead? They'll plug in 3.99. Again, this is where the linearization is happening. So we plug in a value that's very close to 0, namely 0.01. So what is y? Y is -1 over 4 times x plus 2. So I'll take -1 over 4 times x is 0.01 or 1 over 100. I get -1 over 400 plus, I'm going to create common denominators. I'm going to add 800 over 400. That gives me 799 over 400. So in other words, the square root of 3.99 is approximately 799 over 400. And it is an overestimate. You don't look impressed? I will make you impressed. 1.997498. Take 799, divide it by 400. That's pretty close. In fact, if you take that answer and you square it, you can see pretty satisfied. Come on, that's cool. Let's do one more. What should x be for square root of 4.1? -0.1. Very good. So I end up with -1/4 times -1/10 plus 2. Or +1 over 40 plus 80 over 40. And I get 81 over 40. or the square root of 4.1 is approximately 81 over 40, and that again would be an overestimate, which we diagnose from the shape of our graph. If I plug that in, the square root of 4.1, and now I'm going to take 81 divided by 40. Yeah, so if you look at, I can't think of a lot of examples that we're going to come up with, but the sine graph would have been an exact situation where one would be an overestimate and one would be under, because as you can see, we headed to the right and then we headed to the left. So, but you can look at your graph here. As we head to the right, 0.01, we're over. As we head this way, negative 0.1, we're over. All right, I'll post your assignment when you get back. Have a good one.